My name is Varsh Kumar from SRM University AP Amravati. Today I am here to present the project I completed during my embedded system internship at Emertxe Informational Technology Private Limited. The title of my project is Washing Machine using picsimlab. This project is a simulation based on implementation of a fully automated washing machine using a PIC16f877a microcontroller, embedded C programming, and virtual components like LCD buzzer and motor. I will walk you through how I designed the system and simulate the complete logic of a washing machine cycle using microcontroller concepts. Go to the next slide. This is the table of the contents. In this video, discuss the topics: introduction, embedded C, microcontroller objectives, software requirements, hardware peripherals. I mentioned here CLCD, buzzer, fan switches, and project demo, and finally conclusion. Go to the next slide. Okay. What is embedded system? An embedded system is a computer system designed to perform a specific task. It is called embedded because it is built into the device it controls. Unlike general purpose computers, it cannot be reprogrammed from other tasks. Embedded systems combine hardware and software. They are typically based on microcontroller and microprocessor. The software is usually written in embedded C or assembly language. They are designed for efficiency, speed, and low power usage. Most operate in real time, the meaning they respond instantly to inputs. They are found in everyday devices like washing machines, TVs, and printers. They are also used in critical systems like medical devices and automobiles. Embedded systems can be standalone or a part of larger systems. A typical example is the engine control unit in cars. The hardware of a often custom built for specific applications. They use sensor to receive data and actuator to take actions. They follow a predefined logic or program, often using state machines. They do not require human interaction once started. Embedded systems are also used in IoT devices. Stability and cost effectiveness are crucial design goals. They are widely used in automation, robotics, and consumer electronics. In short, embedded system is the brain behind smart electronic devices. Slide. The types of embedded system. This chart divides embedded system into two categories based on performance functional requirements based on the performance of the microcontroller. Real-time embedded systems. These systems respond to inputs within a strict time limit. Examples: airbags systems, peacemakers, industrial control system. The standard embedded system. These operate independently without a host systems like a PC. Example: microwave oven, digital camera. Network embedded system. These systems communicate with other systems or a device via networks like Wi-Fi, Ethernet. Example: smart home devices, routers. Mobile Mobile embedded systems. Embedded systems that are used in portable devices. Example: smartphones, fitness bands. Go to the next type. This refers to the hardware capability of the embedded systems. The small scale embedded system use a controller, low memory, simple task. Example: automatic door toys. Medium scale embedded system is use more powerful microcontroller capable of multitasking. Example: washing machines, printers. Go to the next one, last one. Sophisticated embedded system. High performance systems with real-time OS network and multimedia capabilities. Example: smart TVs, industrial robots, autonomous vehicles. Okay. Go embedded C. Embedded C is a version of the C programming language used to program embedded systems. It allows direct interaction with software components like sensors and displays. It is used to control microcontrollers such as PIC, AVR, ARM, and 8051. Embedded C is efficient, lightweight, and well suited for real-time applications. It enables writing programs that work close to the hardware. The standard C libraries are supported but extended with hardware specific functions. It allows the use of registers, memory addresses, and input ports directly. The programmers can manage interrupts, and PWM signals using embedded C. It helps design applications like washing machines, microwave ovens, and robots. It supports structures programming, making code easier to read and debug. Embedded C is compiled using tools like the X8 compiler. It commonly written in XIDE such as MPLAB XIDE or Arduino IDE. Program starts with main function and include header files for MCU support. Embedded C code is small and fast, making it ideal for resource constant devices. It uses bitwise operators, loops, and conditional logic heavily. Code must be optimized for timing and memory usage. It is often used in automotive, industrial, and medical applications. Bridges the gap between hardware and software. Learning the embedded C is essential for embedded engineering and IoT developers. In short, embedded C lets you control electronics and using code. Go to the next slide. Data types. These C programs are classified: primary data type, derived data type, user defined data type. In primary derived data type, primary data type, these are most commonly used in built-in types: void, int, char, double, float. Void, no value are written. Float. Float means decimal numbers with single precision. Example 3.14. Double means decimal numbers with double precision. Example 3.141592. Go to the derived data type. In from basic types: array, pointers, references. Array means collection of same data types. Pointers store address of another variable. References used in most common used in C++. Reference to a variable not standard in C. Go to the next type: user defined data type. Created by the user for structuring data. Structure means group of variables of different types similar to structure but all members share the same memory. Enumeration means enum. Assigns name to integer. Constants improve readability. Now go to the next slide. Operators in C. Operators in C are symbols used to perform operations on variables and values. They are categorized as unary operator, binary operator, ternary operator. In unary operator, work with single operand. Example increment, decrement. In binary operator, work with two operands are most common. There are subtypes are there: arithmetic operators, relational operators, logical operator, bitwise operator, assignment operator. In ternary operator, a operand syntax means conditions, value if true, value if false. Example: x is equal to a greater than b or a is to b. Assign the greater value. This is all about. Go to the next slide. Is nothing to else to just look at it. If else if nested if switch. A microcontroller is a compact integrated circuit that includes a CPU, memory, and input-output ports. It is the brain of embedded system used to control device and perform tasks. The PIC16f877a is an 8-bit microcontroller developed by Microchip Technology. It belongs to the PIC16 series, which is widely used in embedded application. The PIC16f87778 is a popular due to its simplicity and reliability and flexibility. It is operates on RISC, reduces instruction set computer. RIC means reduces instruction set computer architecture. The microcontroller has 14 KB of flash memory to store program code. It also includes 368 bytes of RAM and 256 bytes of EEPROM. Outputs pins for connecting external device. The PIC16F87778 supports 8 analog input channels for sensor. It includes built-in timers, counters, and PWM modules. The MCU and can perform serial communication using USART, SPI, and 12C protocols. It runs on a voltage of 2 volts to 0.5 volts and it is power efficient. Programming it's done using MPLAB into IDE and XAI compiler. The chip is used in robotics, automations, home appliance, and student projects. It is future make it suitable for real-time control applications. A pin diagram helps in identifying the purpose of each pin like input, output, VCC, ground, etc. The PIC16f877a supports interrupts which allow it to respond to external events. It is well documented and supported by the large community. Overall, the PC16F877 is a versatile microcontroller for both beginners and professionals. Right? There is nothing to worry, just look at it. It is a pin diagram of microcontroller. My PM, sorry, micro PIC16F8 microcontroller. The next slide, a timers. What is timers? A timer is a hardware feature in microcontroller used to measure time intervals. Timers are crucial for delays, event counting, PWM generation, and real-time control. The PIC16F87778 microcontroller includes three timers: timer 0, timer 1, timer 3. Oh, sorry, timer 2. Anything. Timer 0 is an 8-bit often used for simple delay or event counting. Timer 1 is a 16-bit timer suitable for more patient time delays and clock functions. The timer 2 is an 8-bit timer, a pre-scaler and post-scaler ideal with PWM and time-based interrupts. The timers can count interval clock pulses and or external pulses via dedicated pins. The pre-scaler divides the input's clock frequency to extend time ranging. The timers can operate in timer mode or counter mode. In timer mode, they generate time delays by counting clock pulses, clock cycles. In counter mode, they count external events like switch presses. When the timer overflows, examples from 255 to 0 in 8-bit, it can be triggered an interrupt. When this interrupts allows the microcontroller to respond automatically without polling. The timers are essential for creating and non-blocking delays in embedded C. For example, you can blink an LED every 1 second using timer 0. In washing machine project, timers control wash duration, rinse delay, etc. Timers can also use it to create square waves or timestamp events. Proper time setups involves configuring registers like TMRO, T1 CON or T2 CON configuration. CON. Timer values can be adjusted by changing initial count or prescaler values. In summary, timers are vital for time-based tasks in embedded systems. Go to the next slide. A block diagram of microcontroller PIC16. Yeah. Which power ups the system. The microcontroller checks its state and initialize all peripherals like LCD and motors. Switch means pulse stops. This switch is used to pulse or stop the washing cycle in midway, useful for user control if anything needs to be changed or interrupted. Switch for navigation. In a full future design, this switch could be used to scroll between nodes, quick wash, rinse only, or full cycle, etc. In our simulation, it can help represent multiple washing phases or states. Washing machine. The machine should not run unless the door is closed. The microcontroller checks this condition before starting the motor or water flow. At the center of this is the microcontroller. This task all inputs process logic coded in embedded C and send output signals. This is the output signals. This is the answer. Right side we have the output components which are based on the input and logic. CLCD character LCD display. It shows the current status such as washing, rinsing, drying or cycle complete. It improves use experience and makes debugging easier. Buzzer like door open. Control through a digital output pin. Motor, go to the last one. This is a motor. This is a fan also. It simulates the actual washing drum motor. In the simulation, it represented by a fan or rotation animation controlled by the microcontroller during different washing phases. Go to the next slide. CLCD. LCD 16 into 2 character LCD is commonly used to display messages in embedded projects. It works well with PIC16f877a microcontroller using its digital input pins. The LCD has a 16 pins including data pins D to D4 to D47 and control pins RS, RW, EN. We usually use 4-bit mode to save input pins and only 4 data lines are used to D4 to D27. The RS pin select between command and data mode. The RW pin is connected to ground to set it permanently to write no mode. The EN means enable pin is pulsed to latch data or command into the LCD. The power is applied by VDD and VS ground. VE is connected to the pointer meter to adjust LCD constraint. LCD needs to be initialized properly using commands like 0 into 228 dot 0 into comma etc. Use MPLAB into ID and X8 compiler to program PIC in embedded C. The data and control pins are mapped to specific port B or port D pins on the PIC. Example RS is equal to RBO, EN is equal to RBN, RB1, D4 to D47, D7 is equal to RB2 to RB5. Adjustable. In washing machine project, LCD shows messages like washing done or countdown. Timer values or sensor reading can also printed on LCD for user feedback. The LCD is refreshed character by character using loops. No external drivers are needed. Just connect the pins correctly. The PIC 16F877 is has enough input ports to handle LCD along with other peripherals. In summary, CLCD with PIC an easy and effective easy way to display and output in embedded systems. Here is the software requirements to build the project. This is MP Lab. Project is consists of some files, header files, important files, linker files, source files, libraries and loadables. These are required files for projects. This is the codes of this main project. Now go to the picsimlab. I already loaded here. This is the fan. This is the buzzer. These are the switches. RBO, RB1, RB. These are the switches. These are the LEDs. Is a port A and port B. Now I'm pressing switch 5. Then program powering on washing machine. Some types are there. Heavy daily. Slow. Let it dry. Dry only. Wash only. Daily. I am pressing daily. If you want press daily, press long press. Heavy. Select the water level. Auto, low, medium, high, max. Auto. Again I press the long press. I am pressing switch 5, then washing machine will start. Please open. So complete this program, complete and remove class. Okay, again back to the stage. Okay. On picsimlab, using the PIC16f877a successfully illustrates the role of Emertxe programming microcontroller peripherals and real-time logic in automatic household appliances by integrating components such as LCD for displaying messages, digital keypads of for user input, timer for delay and process control, finite state machine of for different washing pages. Thank you all.